Welcome into a very special edition of Everything is Logistics, where we're highlighting some of your favorite space logistics episodes from 2024. Over the summer, I attended a NASA launch where I got to go behind the scenes of a launch day down in Cape Canaveral, Florida. And this trip seriously changed my life. It felt like the culmination of my entire career wrapped up into one. And it just so happens to cover a variety of facets of my lifelong interests, as well as what's going on with developing the next level of logistics in space. Now, back in August, we released several episodes covering this entire trip, along with subsequent follow up episodes with some of the coolest startups working in space logistics. Think of this as a super space logistics episode all in one, so you don't have to dig around for the good stuff. Now, if you don't know me, my name is Blythe, and our show covers topics for the thinkers in freight to help tell the stories of how your favorite stuff and people get from point A to B. Now, for this episode, we are featuring three of your most popular. I love all of the NASA episodes that we've done and all of the space episodes that we've done, but I pulled together the top three that you told me that you liked based on views and downloads. And so we are going to be featuring, just to kick things off, deep space logistics. So that's going to be the first episode you're going to hear. Next up, we are going to cover how to grow food in space. It turns out that's a very pivotal thing that you need to do if you want to colonize other planets and build humanity outside of Earth. You need to be able to grow food for them on a reliable basis. So that was a really interesting episode. And then finally, we're going to round it out with a company called Inversion Space. They are building warehouses in Earth's orbit to be able to deliver goods all across the globe in a little less than an hour. It's really incredible stuff that's going on in and around space, especially when it comes to logistics and building out that space infrastructure and what that looks like. Well, I'm going to link to all of the episodes that we've covered in this regard in case you want to check those out. And all of these episodes experience the most plays in the space logistics category, which is also a category on the Everything is Logistics website. So in case you missed any of those episodes or simply want to refresh, I got you covered. Each of these episodes will play after each other with a little whoosh sound effect to signify the start of the next episode. And I've also got timestamps in the show notes in case you'd like to skip around. But with all that said, cheers to 2025. Thanks for all the love and support. Thank you for helping make this podcast into something that I can do something like this. Go to NASA and attend a launch. This was seriously the highlight of my career. So I appreciate all the love and support again. And I hope y'all enjoy this best of roundup. Welcome into another episode of Everything is Logistics, a podcast for the thinkers in freight. I am your host, Blythe Brumleve, and we are proudly presented by SPI Logistics. And speaking of logistics, we have another incredible episode for y'all today, and we are talking about deep space logistics. Now, this conversation comes from a recent tour that I was given, a behind-the-scenes tour, lucky me, over at NASA for one of their social media programs, basically PR, branding, outreach, that sort of thing. Not that NASA needs any kind of branding or brand awareness. But they have a program called NASA Social where they invite a small number of creators to come get a behind the scenes look as to what goes into a NASA launch. So this is one of several episodes that we recorded on site while on the 2-day tour over in Cape Canaveral, Space Coast, which is about 2 hours south of my hometown, Jacksonville, Florida. And so for this particular episode, we are going to be hearing from Matt over at the Deep Space Logistics Program. And he's basically going to be talking at length just how we get things up into space. Are there trade lanes in space? Getting supplies to and from, the challenges around that. How do you even prepare, for a launch? What kind of supplies go on, a rocket versus a transporter mission, which, a transporter mission is just basically only sending goods, no astronauts. And so, he gets into all of that. It's a really interesting discussion. And then he rounds out the discussion with a lot of Q&A. And of course, I had a bunch of questions being the logistics nerd. So it was definitely one of the most enjoyable conversations and one of the most lengthy conversations that I was able to record while on this tour. And I believe it's about 26 minutes long. So hopefully you will enjoy this episode, and I'll see you on the other side.
Contract that we issued for the Deep Space Logistics contract. We're planning on onboarding another spacecraft. The objective of this is for a commercial launch environment or commercial resupply environment for deep space. Starting with the moon and then working on our way on to near-Earth objects in Mars, Venus, wherever we need to go. So it's really just establishing a deep space supply chain. Up until this point, we've had other commercial endeavors here at Kennedy Space Center. So commercial resupply service for the International Space Station. Northrop Grumman has the CRS vehicle, their vehicle. There's also the Cargo Dragon from SpaceX, along with others. We've also had international resupply services from JAXA, which is the HTV vehicle, and the cargo resupply from ESA as well. And the name eludes me, but there was a whole bunch of these things. So we've established a resupply service for the ISS, which is above us, flying around at about 300 to 400 kilometers. It's about 7 to 9 kilometers a second, depending on where you are, relative on the Earth. If we're trying to go further, the moon is much further away than low Earth orbit. It's much more difficult environment. The orbit that we're going to is very elliptical, very unusual, and so it provides a lot of challenges for us, a lot of things that we didn't have to face with ISS. The first of which is a lag time. We have to have a lot of autonomy with the gateway that we didn't have to do with ISS, because there's always people on ISS. There's no communications delay, it's right above us, but when you're dealing with something as far away as the moon, that 2-second delay can mean the difference between a crash and a successful dock. So the vehicle is going to have to learn and adapt by itself, and this has provided us with a massive challenge. Analogy to this would be, if you wanted to program your little robot to, for example, come down this road and then take a right turn and park by the couch. You know exactly where the couches are, you know how far it is from start to finish, where it needs to turn, how far it needs to turn, and where it needs to get there. But imagine if you weren't exactly sure where that corner was. You knew you had to do a right turn, but you weren't exactly sure where. So you have to have that robot have a sensor to measure where the couches are. It's not going to be a perfect measurement, and it's going to have to update that and update its estimate every time step. So imagine this not just in 1 degree of freedom, but in 6. And that's the challenges that we have to face with ISS. In addition to just ISS gateway. In addition to this, gateway's a lot smaller than ISS. So as we have our logistics vehicle coming in close to the gateway, it's about this big, so it's about 1/6 of the size of where it's docking to. So when it slows down, it's firing those jets. You ever see jets take off from the aircraft carrier? You have that big panel that comes out, the jet blast deflector, to make sure the crew doesn't get blasted off the deck of an aircraft carrier. That's the force that these jets are generating. So imagine coming up to a ship and you're blasting it with your jets. You need to slow down, but you're also pushing your ship away. So there's this coupled relationship between your ship and the space station. And so it's constantly pushing and pulling. So this is another challenge that we're trying to deal with. In addition to that, we've got these rollout solar arrays here. On ISS, these solar arrays are fixed. They're made of silicon, they're rigid, and they can be buffeted and they move and they wobble. But these solar arrays are roll out. There's a single stick in the middle, and they roll out, fold out like a, almost like a sheet, or like a shade, right? And so these are going to wobble and flex all the more when you're blasting them with these jets. So that's really what we're dealing with right now, and that's a lot of the challenges that I deal with. In addition to that, I work a lot with lunar environments. So the lunar dust, as you might know, is very dangerous, very abrasive. Astronauts bring it in, they get something called silicosis, which erodes the lungs. It's also very sharp and abrasive, so if you get that in any moving parts, it grinds down those gears and makes them pretty much useless. So the longest time we spent on the lunar surface prior to the Artemis program was a total of about 73 hours during one of the Apollo programs. And by the time they came back from the 73 hours, everything was dirty, broken, and falling apart. So it's amazing that no one died during the Apollo program, at least in space. So some of that dust is eventually going to be cleaned to the outside of Starship. We did some tests with various materials, especially untreated aluminum, We spun that up to 400 Gs and the dust didn't move. So this stuff sticks onto aluminum, wedges in the cracks, and the G-force is not enough to pull it away. So it's going to survive the launch environment from the lunar surface to Gateway, and we're worried that when it docks, it might transfer some of that dust because the charge dynamics are more powerful than the gravitational field in orbit. Of course, the gravitational field's relatively weak. So that's just some of the challenges. There's also thermal challenges, there's radiation challenges, there's optical challenges. If those surfaces get covered by lunar dust, how are you going to dock? Are you going to have enough clearance to dock because you're using optical sensors to dock? Is it going to damage the docking mechanisms? Is the resupply service going to carry enough oxygen and nitrogen to resupply the habitat? The micrometeoroid or orbital debris environment in North orbit, as you might know, is very dangerous. But in the moon, it might be less frequent, but they're traveling much faster. So where we might have stuff flying around at 11 kilometers a second in North orbit, they're 20 to 100 kilometers a second out by the moon. So if one of those punctures, you have to have stronger, more durable materials that can handle these very rare, very small, but very high-speed punctures. And then salvage the space station in the event of catastrophic failure. There's no emergency return for the Gateway. It varies with the ISS. In the ISS, you can come back to the Earth's surface in as little as 90 minutes. But you're up, if you have a catastrophic event, you're stuck up there for at least 3.5 days, but probably closer to a week, week and a half. So it's a lot of moving pieces. It's a lot of ways that our astronauts can die, and we don't want them to. So questions? I guess I'll pick it now.
So I'm hearing you mention like a lot of challenges and problems. I was wondering how you kind of like go through these problems or discover them. Like obviously there's some of it that you guys have experienced before with the ISS, but this is a completely different kind of mission. What more problems are you expecting? And then how do those problems affect your kind of timeline for this development?
So sometimes I wish our engineers understood that this is a completely different kind of system, because we have a lot of people coming in from the ISS that are very experienced, very knowledgeable, and very talented, but there's a tendency to try and roll over ISS methodology into a completely new system. And so that's usually where we identify these problems, is that we try to use old methodologies to solve new problems, and then we have some kind of disconnect. And we run some analyses, and it's like, oh, look, this is terrible. For example, we did the first analysis of Starship docking to the Gateway, and it's spinning. It's just tumbling. So we had to take a step back and like, okay, let's figure out how we're going to fix this. So it's a lot of analysis. It is a ridiculous amount of meetings. However meetings you imagine that we have to sit through to make ISS or Gateway a thing, probably double or triple that, because it's going on constantly. And usually the calendar has 2 or 3 meetings going on at the same time, and you have to pick and choose which one is closest to your expertise to sit in. So lots of talking, lots of, I think it's a lot of a very candid work environment. So there's always egos going on, but I think NASA's a pretty good place where if someone says this is wrong and this is why, people are more receptive to that. Whereas I think if you do it at a company, it's all about dollars and cents. And so it's like, no, that's too expensive. Granted, that does happen at NASA as well, but not to the same degree. Yes.
From a cargo perspective, I get like fuel and oxygen and things like that, but what are some other items that you're regularly shipping up to space? And then what are maybe some backup items?
So that's a very good question for logistics. So let's start with this. So there are 2 types of deliveries that we have for the Gateway. One is what we call a fast transit, which goes from the surface of the Earth to the Gateway in about 3.5 minimum days, usually about a week, to do all the flybys and burns. And then we have a slow transit, which means we can deliver more cargo over a long period of time. And what we do is we come from Earth, we have this big slingshot of the moon, because the Earth is orbiting the moon. So we use that momentum and fly into space, and then we slow down out by the sun, and when the moon has come back around again, we can use its energy to slow us down and put us into the orbit that we need to go into. And so by doing that, we can handle more cargo, but you're also in space for 180 days in a pressurized tube being blasted by radiation. So you have to consider what you're transporting. Is the food in a radiation-safe container, and how long can it last in orbit? Because if you're delivering food, it might be a problem. If you're not delivering food, you're delivering outfitting equipment for Gateway, payloads for the power payloads for the power payload racks, or maybe you're delivering astronauts' diapers. So they wear diapers on the lunar surface because they're out in EVA for 8 hours at a time, or uniforms, or toothbrushes. Then you might be all right floating around for 180 days. So there's the standard consumables that you might expect: food, water, Norris tanks, nitrogen, oxygen resupply service tanks. And then there's, like I said, toothbrushes and consumables. There's other things that the astronauts have to work on a regular basis. So there are parts that are designed to be replaced after a certain amount of time so they don't fail. So these are standard maintenance stuff that you have to do with Gateway, just as we do with ISS. What else? The toilet. We're delivering the space toilet, and that goes up with every mission currently. That's kind of what we're thinking we're doing. Still in movement. We might have a permanently mounted one later on, but that's what we're doing.
What about like female hygiene? Because I heard like the first woman that went into space, she was sent with like, women will get this. Yeah.
So there's actually, I mean, it sounds like it was a complete ignorance, right? And in a way it was, but it wasn't, I don't think it's painted quite the right way.
I heard like 1,000, so 100 is a little bit better.
Yeah.
Exaggerated.
Yeah. I don't know what the number is, but we certainly did not know what the female body would do in space. And so it's
interesting.
better to have an extra amount than not have enough. And that's the same case. I mean, you've got to think when the Apollo astronauts came back from the moon, they were quarantined for 2 weeks because we were worried there would be space germs and that they would contaminate all of Earth, even though there's asteroid impacts in the moon and we're contaminated with rocks all the time. So there's always this extra step of risk averseness that we take to provide too much. They'd rather have too much or be too safe rather than not enough. But I don't know specifically how many we're sending up. I think we have a better understanding of biology at this point. So I wouldn't expect an entire element.
I would imagine that's a lot of space that it takes up.
Quick question, and you might have already said this and I missed it. Is only NASA operating Gateway or are other space agencies taking part?
Good question. So Gateway is an international effort. So Maxar, which is this one here, this is the power and propulsion element, and that's made by Maxar, which is an American company. And then Northrop Grumman is manufacturing the Habitation and Logistics Outpost, which is their first habitat. After that, it gets more international. We have the Esprit refueling module, manufactured by the ESA, and then the International Habitat, manufactured by the ESA and JAXA. In addition, JAXA is sending a resupply service called their HTV-XG, resupply cargo, just like the LM. They're actually working with it very closely. I'm going to Japan next week, as a matter of fact, to meet with JAXA to talk about this. And then we have the recent new addition to our international partnership, which is the Mohammed bin Salman Spaceport, which is the UAE participating in building the airlock module. So it is currently international. The airlock was originally slated to go to Russia, but there's been an issue. And so we've given it to the UAE instead. We're always looking for more international partners to participate, especially with science payloads and other research opportunities. Of course, the lunar base on the surface is still wide open for participants to collaborate with us and make that work.
Will there be lab facilities or lab module?
So it is, the whole thing is a flying laboratory with a few rooms to stay in and sleep in. To say there's a dedicated laboratory, not necessarily. Everything's multi-use. It's a lot smaller than the ISS. The ISS is about the same size as a 6-bedroom house. This is about the size of a studio apartment on the inside.
Wait, go back to what you said.
The ISS is a 6-bedroom house.
It's about a 6-bedroom house on the inside, yeah. So this is the ISS here. Right behind you, you can see humans relative to Gateway right there. They're crawling around on the airlock module, like literally right behind you. So that'll give you the scale of what humans are to Gateway. And of course, the inside of that volume is mostly filled with cargo. So we have this passageways, and they have the closet, which is the logistics module. So there's some space to move around and to stay in. But really, there's not that much. That being said, if you look at the room we're in right now, it might seem like a decent-sized room, but when you remove gravity, you have all this stuff available above you. So small spaces tend to become a little bit bigger in space.
The reason I ask this, just curious as to, I realize the purpose of Gateway is different than the purpose of the ISS. Just wondering how much of it will be used for research, because again, you're in an environment that we haven't done yet, like you're orbiting the moon. So we're gonna have to retest a lot of the things that we found out through testing on the ISS. Like, I was just curious about some of the instrumentation that might go in it. Is there someplace I can look that up? I go to NASA.gov, I haven't found anything like that.
There is.
You can get back to me if you like.
Yeah, well, I'm going to get back to you. There is a place that covers these scientific instruments. It's not easily found yet because I think part of that is because there's still a little bit of uncertainty.
Gotcha.
There are a few experiments that we know are going up. One tests radiation over time, and there are several radiation sensors being placed inside Gateway. There's also a materials testing bed, which will be on the outside. And there's a ton of sensors. I'm not a human factors
One of the
person.
things we're trying to apply is the Hermes Space experiment. You can Google that, it's all over
Thank you.
the Hermes, H-E-R.
Yeah, I'm purple.
Oh, okay, okay, very good.
So it's a lot of human factor stuff where the biggest priority is making sure our astronauts are going to be safe in a different environment. So that's the biggest priority. A lot of those things go into that. As a GNC engineer, I'm not intimately tied into that, but
Gotcha.
lots of that.
Thank you.
So I was wondering about, obviously you guys mentioned sending people back to the moon and experimenting in, lunar orbit. I imagine you guys have many future missions planned and operations. Like, what's the kind of timeline look like for how this is going to be used over time? Is it going to last as long as the ISS? Is it a temporary kind of thing until you get something better over there?
So there's two approaches to that. One is that we do have a notional timeline, and that carries us up to 15 years, and I think it's like Artemis 11 or something, and that's what's available out in the public, right? We have this timeline that lasts about 15 years. There's also a possibility of extending that. The main purpose of Gateway is it's a moon to Mars thing, right? So this is basically our Mars spacecraft, our interplanetary Mars spacecraft prototype. We're learning what works and what doesn't work. So the short answer is it should last 15 years, but it's a big investment, and just like most of NASA projects, it's reasonable to expect it's going to be extended at least a little bit.
Do you know what the current schedule is when Gateway is supposed to actually be up there? And do you think that that's realistic and it's actually going to happen at that time?
There's a couple ones. I mean, there's the one that we currently have in the public, and then there's the working model, which has that schedule slip to the right, and that's just the nature of space exploration and technology development. So the one in the public, not as optimistic, not super optimistic, but optimistic. Things are going to keep moving around, and really that depends on the progress of things like Starship, which is a huge unknown right now. That's our first human landing system. It's making tremendous progress. It's moving very quickly, but there's a difference between having a re-entry system on Earth and having something that can land our astronauts on the moon. We've seen recently that we've had a lot of landers. Think of Apollo, right? It was short, it was squat, it was wide, so it didn't really tip over. The past two landers that have gone to the moon have both tipped over. Because we're underestimating the challenges of keeping something upright in a low gravity environment with unknown surface features. So something like Starship, which has a very flat bottom, needs a very flat surface. So that's just one example of something we're concerned about, that we needed a few test demonstrations to make sure they can do it. Not saying they can't, of course, everything's possible. It's just a matter of technological progress, how quickly they can test, how quickly the FAA lets them test, how quickly we can clear the water so that when it's splashing down the ocean, it doesn't kill anyone.
And how do you test a lunar landing? Like, is it real all simulations, or are you building an environment that facilitates points of like?
Yes to all the above.
Okay.
We have high fidelity computer simulations that test lunar landings. Thanks to the Lunar Reconnaissance Orbiter, LRO, Lunar Reconnaissance. We have a very high fidelity map of the South Pole lunar surface. So we know what that environment looks like, and we have some test sites picked out. Now, no matter how high fidelity it is, there's still some uncertainty, there's boulders we didn't see, there's places in shadow. And there might be maybe some noise in the thruster that it doesn't thrust exactly where it should, and it ends up a little bit off course. So we have to plan for those contingencies. And so it's a lot of simulation based. Now, once we get the simulations working, we do have some things like a gravity offloader. I'm not sure if you guys have gone to Swamp Works or if you're going there, but if you get a chance, it's a great place to go. They have a big lunar dust bin and a gravity offloader that simulates lunar environments. That doesn't have thrusters in it, right? It's just a big dust bin, so we don't want to fire rockets inside of a closed room like that. But we can simulate the dynamics and the resistance that would be generated by a thruster. So there's a lot of different ways we can test these things, and we do all of them.
Thank you.
Other questions?
What are some of your favorite supply chain or logistics facts for deep space?
Supply chain logistics back. We went to a conference in 2019. It was the Air Cargo Conference, and that was in Nashville, Tennessee. They put us in the Omnia, which is the nicest place I've ever been on a government dime. So I tell you, it's not usually you're in a Holiday Inn or something like that. We were in the Omnia, and it was attached to the Country Music Hall of Fame. And all these guys in the logistics did this conference about air cargo and logistics. They were all rather well. One guy was giving away bottles of his own homemade bourbon brand. It was nuts. And so it was kind of interesting to be in touch with that crowd, because usually I'm more with the academic crowd. And so meeting with these people and getting their perspective on what logistics looks like for the closest analogy we have, air cargo, moving things from one place to another, was kind of eye-opening. And they were at first kind of confused, why is NASA talking to us? But once we kind of said, we want to do what you do, but in space, it started to make a little bit of sense. So I'm not sure if that's really qualifies as the most interesting, logistics fact. We still don't know how to do logistics in space because everything's moving, everything's changing, and you can't have a set route, right? You can't have a set subway line. There's always some ambiguity.
Are there trade lanes in space? Like, are you establishing maybe trade lanes or trade routes in space?
Yeah, so, I mean, everything's moving around everything else. So a trade lane that might work one day isn't going to work the other day. So take the Voyager 1 and 2 spacecraft, for example. When the Voyager 1 and 2 spacecraft were launched, there was this once-in-a-century alignment of planets where you could just get flyby after flyby after flyby. And they figured this out, and they loaded up on the rockets and launched as soon as possible. And so that alignment won't happen. It's about to happen in another 30, 40 years. So we're thinking about doing it again. But when they launched, it was just this perfect alignment. So you can't have a supply chain that consistently goes to, let's stop off at Jupiter and then stop off at Saturn and then stop off, because there's just not enough fuel to do that right now. We need a new technology to enable that kind of delta V. And so, how many of you have seen The Expanse? Yeah. If you haven't, you should watch it. It's excellent. So you can see that the big change in the Advance was when they all of a sudden discovered this new drive that ended up killing the guy who made it, but it was so powerful. It could accelerate so quickly on so little fuel. I forget, it's like an antimatter drive. I don't remember what it was, but it was completely game-changing. We need something like that to have these supply chains, to have these regular service to and from Mars, or to and from wherever. But until then, that regular service to and from Mars is every 2 years, 2-point-something years, because that's when Mars and Earth have the right alignment for home and transfer.
Is there anything you learned from the private sector of air cargo, that conference, that you apply at NASA?
There's a lot of things about, it was a lot to do with cargo packing and how they manage different shaped cargoes in different iterations. So a lot of the stuff with ISS is pretty standardized. We've had it for 20 years. We resupply pretty regularly. So we know what we're doing with that. We have specialized software that fits the optimal configuration to get the most volume, because we end up being volume limited before mass limited. So if we can deliver 10,000 pounds or something, we can only fit like 8,500 before we're just packing it in, right? So they have this software that optimally fits everything together. But if we want to do different cargo, if we want to take on one load, offload, and put it in another one, and do it pretty rapidly, it takes up a lot of astronaut time to fit this stuff into place. So we're learning a bit from the industry about how they do their loading and unloading and handling these changing loads in order to best accommodate a variety of customers. And so that's something we've taken back, and we had a bunch of crowdsourcing challenge where we reached out to universities and even high schools and said, what do you think we could do to best manage our cargo? And we have all kinds of really interesting ideas. We have a automatic cargo loading and unloading system with like cheese wedge shaped boxes. It was pretty cool. And that was by the University of Michigan, University of Michigan. And they did a really cool job with that. But that's just one of many. So it's just collecting ideas right now.
Michigan
Wolverines rule, okay.
Oh, sorry, did I steal somebody's question?
Yeah, I'm gonna go with this guy first.
I was gonna ask, what excites you the most about all of this?
So I come from a background of academia, and so we've worked a lot in publishing papers and writing down. It's a lot of math, right? And my advisor was very much an academic, focusing on, it doesn't matter if this can be applied today, it matters how revolutionary this will be in 100 years, taking the Einstein approach to things, right? But I'm really focused on getting this stuff, because we're publishing so many papers, it's such a big academic, big talented academic community we have in the United States and around the world. Making that into hardware is a huge challenge. So what excites me the best is when I take this theory and I say, let's try to do this, and everyone tells me how bad it is, or how many ways it won't work, because that's a whole list of challenges that just adds a bunch of nuance, many different layers of nuance. I might have a simulation that works great, but as soon as you start adding noise, it starts behaving unpredictably. So that's what excites me most, when I come across a practical, real-world problem that people are like, no, you can't solve that. It's like, well, let's try anyway. So those those kind of challenges.
Going back to the expense that you brought up and this super material that could just propel us into this trade belt or based on your experience and expertise, what are your predictions?
It's nothing quite that exotic. Our next step is nuclear thermal propulsion. And it's not actually a new technology. We've had this in some form or another in the past 30, 40 years. I forgot the name of the project, and it was canceled in the 80s or 90s. But it was a nuclear thermal propulsion device, and it's pretty much the next step we need in space. So that can cut down our Mars transit time in half. It's probably what we really need to get off the ground. Fortunately, we're working on that now. Our Mars transit vehicle should have a nuclear thermal propulsion device.
By when, do you think?
Ask Congress. If we have a continuing budget, then we can get it done pretty quick. The biggest challenge to NASA is every 4 years our priorities change. We need to be insulated from that.
And assuming NASA, the government approved your NASA's budgets, when would that? How long to?
At the soonest rate, if we were back up to Apollo budget, which was 4% of GDP, by comparison, we're 0.5% of GDP right now. Or sorry, 0.5% of the budget. If we were back up to 4%, we would already be on the moon. Again, we'd have a base, and I think we'd be thinking about Mars.
Wait, you said it was 4% of the GDP during Apollo.
Correct.
And now it's?
It's 4% of the national budget,
Yeah.
GDP, 4% of the national budget, and now it's half of a percent. So it's 1/8 of what it was during Apollo. So
it just kept getting lower and lower.
So launch rockets.
not necessarily lower and lower. It actually got cut after Apollo, and it got cut a couple times, and then it's pretty much stayed there. So it stayed at about 0.5 or half a percent of the national budget for a long time. And during that, with that very small percentage, we have ISS, we have SLS, which is not the best rocket in the world if you compare it against Elon's Starship, but with 0.5% of GDP, 1/30th of what the DoD gets, we still managed to do that. We're still trying to go to the moon. So,
Well, and that's also why they've been putting so much into low Earth orbit, that we have the commercial partners
right.
and everybody that's buying it.
It's precisely true. So if we have a very talented commercial industry that can lower the price, which is what exactly they've been doing, then that enables us to go forward.
All right, just pop it back in to list out a few takeaways that I thought were really interesting. One, which is Matt, when he says, we still don't know how to do logistics in space. I thought that was really interesting, that they are still learning how to do that entire process. Another one was obviously the air cargo conference that they attended back in 2019, where they were, learning from the private sector on how to, better pack their own rockets and transporters and all of that good stuff. Another thing, if you were watching the video version of this conversation, then you might have noticed a gentleman in the background walking back and forth and fixing something. Well, that was actually a NASA engineer, and he's walking back and forth as if he doesn't have better things to do, but he just notices a tiny detail that is messed up within his working space, and he has to fix it right away. So I love that mindset, because there was like a small light that was out in the display case, and so he has to pause his day and make sure that thing gets fixed, so it represents his program that he works for, the Deep Space Logistics program, that it is represented properly, because do have to give him credit. The light that was shining was on the Deep Space Logistics logo, which they have a really cool logo. Hold on, I will pull it up. All right. And another thing that I wanted to bring up, because there's so much to digest from this trip that I just keep going back into my notes and finding new things that I want to share. And so this was one of the resources that they shared with us on the first day of the tour, actually the first classroom session, from the National Oceanic and Atmospheric Administration, that is the data that they were providing, or the insight that they were providing, not data data to, that they were providing in the first classroom session on day one of the 2-day tour. And obviously, this is a deep space logistics episode, so let's talk about, a little bit of the logistics of this satellite that is going up into space. I'm obviously going to get into more details on that specific episode. So if you're interested in everything that goes on within launch day, make sure that you listen and watch that particular episode. But for this one, it's just a really cool, just like photo gallery that the NOAA creates for all of their missions, and they go behind the scenes on everything. So it's really cool from a transportation perspective of basically shipping this satellite over to Cape Canaveral and getting it ready for launch. So on this blog article, which I will share in the show notes in case you want to download some of these images, because they have the download option right on their site. So they talk about the satellite itself and shipping it. You can see it here in this photo. It's a U.S. Air Force plane that shipped it, and then it looks like a Chevy truck that is pulling it out of the plane itself. And if I read a little bit of this about the shipment to the Kennedy Space Center, and it says on January 22nd of 2024, the GOES-U team carefully packed and shipped GOES-U from a Lockheed Martin facility in Littleton, Colorado, where it was built, integrated with its instruments, and tested to a facility in Florida, where it arrived on January 23rd and will undergo final preparation for launch. They say shipping a satellite is no small feat. GOES-U is the size of a small school bus and weighs over 6,000 pounds. And after packing the GOES-U in a high-tech shipping container that acts as a mobile clean room, a crew drove the satellite to Bucky Space Force Base in Aurora, Colorado. Still can't get over the fact that we have a division of the military called the Space Force, which they actually kind of have a really cool logo. But the article goes on to say that they loaded into a C-5M Super Galaxy cargo transport. Also, crazy names. Space logistics really has like the most fun like branding. Space Force, Super Galaxy, cargo transport. But the next stop was NASA's Kennedy Space Center in Florida. So if we scroll through, and as I'm scrolling through on this webpage, Jesus, is it 1990? This website that is also linked in the show notes, they talk about that entire shipping process. I don't know that I'm going to go through it and read all of these. I feel like, if you want to read it, you can go through it and read it yourself. But as I come to the end, where they actually show the satellite that's inside of the launch vehicle, which is really cool to see, because and as I'm scrolling through, you can see the launch vehicle being attached to the rockets, which is the Falcon Heavy with the double boosters. The Falcon Heavy is one of the rockets by SpaceX, and then it has the double boosters on the side that are infamous for detaching from the rocket and being able to land at the same time, or not damn near close to the same time. But they take off with the rocket and then they detach and they land on their own launch pads after the fact. So that is the satellite being attached to all of that before it actually takes off. So obviously they've gone back through and updated this website with this post with some of the images after the launch was successful. And so hopefully you enjoyed a little bit of that scroll through the transportation process, because it's quite funny to see one of these launch vehicles, because I think it was the first day that we were at the NASA tour, this is just sort of a little bit of a sidebar, we were going from building to building and checking out just different parts of the tour. And on one of the stops, because we would literally just drive out of one building and it would be a 2-minute drive to the next building, and we would park over and get out and do our thing. Well, on one of these pathways, and one of the times that we were doing this, there was another one of these vehicles for a Starship, not Starship, it was for the Starlink satellites, Elon Musk Starlink satellites. There was a Starlink launch the very next day, and so a rocket or I guess, what do they call it? The launch vehicles that carries all of the Starlink satellites, which the GOES-U satellite is significantly bigger. Like we just heard that it's the size of a small school bus. That the Starlink satellites are not as large as that, and so they there are a lot of them that are sent up in a Starlink transporter mission, and so that was blocking the roadway. And hold on, I will bring up that clip right now. And here's that video of that rocket actually causing a traffic jam for one of those routes that we were taking. And then one more last thing I definitely wanted to show everyone is we talked about the rocket boosters, that both of them come down. And so for one of the creators that I follow over on Twitter or X, he actually posts a lot of these photos and the barges that ship, different launch pads, and I guess it never really occurred to me until this trip of just how often rocket launches are actually taking place. As a Floridian, maybe 2 or 3 times a year growing up, but over the last few years, it's like 2 or 3 a week now. So it's happening very frequently. There's also 22 total launch pads, I believe. And so for a lot of construction that goes on for launch pads, or as they're getting replaced, they have to ship those things in. And so it's really cool to be able to see some of these images. And that one of this image comes from C. Nunez images over on X. And this is one of the launch pads that are being shipped in, and it's being constructed. There are a few other images here. We talked about the rocket boosters. You can see one of the rocket boosters right here. Like, isn't that incredible that this is essentially a barge that is built for the rocket boosters to come back and land on? Let me see if I can get rid of this. Then there are a couple just more images that I wanted to show for, we're tugboat respecters over here. So a tugboat pulling the barge with one of the boosters that are on it. This comes from Jerry Pike over on X. And I just think these are incredible images, that these are the boosters that are landing, responsible for a rocket taking off. And then all of a sudden, they're responsible for these boosters landing back on them. And you got the tugs pulling the barges, going right back into the Port of Canaveral right there. So just really, really cool stuff. And just, for me, it's just, I think it brings it all home about how much logistics really goes into this entire process. We're still trying to figure out new ways and cool ways to do logistics here on Earth, and to know that in space, they don't exactly have it all figured out yet. And you have some of the smartest minds in the world and human history, really, that are trying to figure out these complex problems, and they're going to a variety of sources to try to get those answers. So it's just really cool stuff all around. So I hope you enjoyed this deep space logistics episode. This is a reminder that we have several episodes in this series, I believe 5 to start with, and then we'll start scheduling some interviews in the future with some of the meteorologists that we met, some of the forensic meteorologists that were on site, to talk about different weather patterns all across the United States, how that impacts the shipments of goods. And then we will also be talking to some of the experts, hopefully Matt included. We're trying to get him on, a future show, so we can ask him some more logistics focused questions. So all that to say, hope you enjoyed this episode. Be sure to check out the other ones and hit the link in the show notes in order to watch the video version of this, or to see other videos as part of our space logistics series. So thank you guys again. Welcome into another episode of Everything is Logistics, a podcast for the thinkers in freight. I am your host, Blythe Brumleve, and we are proudly presented by SPI Logistics. And I've got another great episode for y'all today, and that is part of our space logistics series. And in this particular episode, we are going to be talking about how to grow plants in space. Now, you might be thinking, why do we need to even think about growing plants in space? Like, what is the possible benefit that could provide? Well, on a recent NASA behind the scenes trip. I can't even believe I get to mutter those words, behind the scenes trip of a NASA launch and also a SpaceX launch for the GOES-U satellite. I was honored to be among this group called NASA Social, which is essentially a PR effort from NASA and from all of the thousands of workers that work for the company in order to raise brand awareness around what they do. Not that NASA needs brand awareness at all, but be able to give creators from all walks of life an inside look as to what goes into a NASA launch. Also, SpaceX was part of this mission because it was a mission for the GOES-U satellite. And so, just a little bit of a background on the reason that I was at NASA is because there's this NASA social thing or program that they have, and periodically throughout the year, they used to do a lot of them pre-COVID. Now, post-COVID, they've had a couple of these NASA social events where they will invite influencers, creators from all over the country to come and get, sort of a behind the scenes tour of a launch, hopefully be able to witness a launch. I was very lucky in that this was my third or fourth time applying for this NASA social program. Finally got there, was able to do the tour, got accepted into the program, I guess it's considered a program. Anyways, but one of launches are very testy because of the Florida weather, especially in this time of year, which is June. So summertime, rainy storms in the afternoon, damn near every day in the state of Florida. So launches can be a little, the timing is important. And so for a lot of these folks, it was kind of waiting on pins and needles, just hoping that you will be able to see the launch at the end of the 2-day tour. We were lucky enough for that to happen. So basically, it's 2 days of recording content all over the place, doing different tours and talking to different folks from different positions all over NASA, which was just incredible. So this is part of, I don't want to give an exact number right now. I'm looking at about 5 episodes, but I don't want to limit myself to just 5 episodes because I met so many freaking smart people on this trip. And so I will be talking to more of those experts, especially when it comes to logistics and weather and how both of those things affect, supply chains all across the globe. So that is coming soon. But with all of that said, in this episode, going to be talking about how to grow plants in space. And this is one part of the tour that was just endlessly fascinating to me. You can see the plants behind me. If you're listening on audio, you can't really see it, but you can kind of visualize it. But I'm a plant mom. I have probably close to 100 plants in my, small, duplex that I live in Jacksonville, Florida. And so I'm a plant enthusiast. And so when you think about the mission of NASA, the mission of SpaceX, and that is to extend humans beyond Earth. How do you make that happen? What are the logistics behind making that happen? And one of the key aspects of that is feeding your astronauts, feeding your smart people that are in space. And so that's exactly what this department does. And so I was honored enough to see that department behind the scenes and get up close and personal with a lot of the different programs that they're doing, a lot of the different testing, how they're using technology and plans together, what kind of foods that they actually transport up into space. And so if any of that is interesting to you, this is going to be probably a really good episode for you to listen to. So hopefully you stay listening. Hopefully you stay watching. This is I will say this is an episode, and all of the space logistics episodes, honestly, are going to be better viewed on YouTube. So if you are listening to the audio format, I'm going to try to explain it as best as I can, but to really get the full visual of everything that's going on in these space logistics episodes, you really want to watch the video version that's over on YouTube. Just search for Everything is Logistics, and you should be able to find that. And we will also work on creating a landing page for all of the space logistics episodes, and I'll link to that in the show notes just to make it easy for folks in case you do find this in the podcast format and you want to be able to watch the video format. So with all of that said, let's get into it. Okay, so sort of set the stage a little bit for this video. This is so we're inside one of the NASA buildings, and we're being taken from sort of room to room, from expert to expert, and just learning more and more about different things. So in this first clip, I'm going to show you the entry to the sort of space plants area, which is really cool. I'm probably not going to do this for other videos, but it is cool for the space plants area because you have a lot of botanists in there. You have a lot of people from all different kinds of career backgrounds that are working specifically on this issue of trying to grow plants, trying to test them, and trying to test, different growing conditions with or without water, with or without different lighting. But before we get into that building, before Matthew, the tour guide host, and one of the botanist experts that are working for NASA, I'm going to let him kind of take over. But first, I wanted to show you this sort of like walk-in part, which is really interesting because they have, different, big murals in case you're just listening. So they different murals on how they're using different space, plant growing, just, quotes on the wall, things like that. But in this next video, it's kind of funny. You can see that they have a little bit of a sense of humor because they have aliens that are growing plants, and it's on one of the doors very clearly. It's aliens, and, it's probably just poking fun at a lot of the different jokes. And then, as we're walking into the building or into the room where Matthew is about to start giving his part of the tour, you can also see this sticky flooring on the ground, which you can also hear that as you're walking in, everybody has to step on this sticky floor to get rid of anything, any kind of contaminants that might be on your feet. So I thought that was really interesting. And, I wanted to make sure that y'all saw that. So with all of that really said, I'm going to play the Matthew's intro, his basically what his entire department does.
Chamber area. So we basically do all of our ground research to figure out what's the best way to grow crops in space. Here we do a lot of our screening in terms of what's the best crops to select, but also can we grow crops in environmental conditions that are relevant for space. So for instance, here on the ground, this is basically where we would be. We study different hardware systems, different technologies, also human factors testings. We do have taste testings because what we grow, we got to make sure it tastes okay for the crew because that's important. The psychological aspect of crops in space is, of high value because astronauts, when they are in space, they do lose weight. And so there's a phenomenon called menu fatigue. Their diet is mostly packaged, and so there's not a lot of diversity, and sometimes fresh crops can actually help solve that, and so that's a big place where plants actually can be of benefit. But also, we utilize the International Space Station because it is a platform where, or even a laboratory where we can have access to microgravity, right? You have to imagine trying to grow crops when there's no gravity. Using water behaves totally different. It actually becomes a big challenge when we're talking about growing crops. And so right now on the ISS, you can see we've got these two big logos here. These are our two main plant growth platforms. One is called the Vegetable Production Chamber. We call it Veggie. That's our simplest chamber. It's just basically lights and fans. And it actually, the plants we grow in there share the environment with the crew. The more advanced system is the advanced plant habitat. We're done with our rain for today, it looks like. So the advanced plant habitat has over 180 different sensors. It's completely sealed and closed. Pretty much you can control your CO2 very precisely, but also has more advanced lighting and watering, active watering capabilities. And so we've basically been growing crops in these two platforms since 2014. But still, we've got a long way to go. And so basically from ISS, and as you may know, ISS will be retiring by the year 2030. And so the next platform is Gateway. Gateway will be in a further out orbit, what we call cislunar space. It will allow us to have access to a higher radiation environment. It will be quite small smaller than the ISS, but still valuable in terms of allowing us to further plant research. And then of course, we are going back to the moon. And so we are working actually with the Canadian Space Agency on how we can have different demonstrators for growing crops on the surface of the moon. But also the lunar surface is going to be a huge opportunity to get practice for when we go to Mars, which is next. So we've got the Mars Transit Vehicle area where plant growth will be required. That's a 9-month trip at least. And so then we're talking about moving away from research and actually utilizing plants as a supplemental food option for the crew. So it's going to be even more important that we figure out, what's the best in terms of food safety, or what's the practical or the most beneficial crops for a transit mission. And then surface habitats, of course, that'll allow us to grow, in larger footprints, larger crops, even staple crops like corn or soybeans, things like that, or even utilizing techniques such as hydroponics. So you can see in all of these aspects of space exploration, plant growth research or plant growth as a supplement to the diet is going to be necessary. All right. So again, this is just a high-level roadmap, but you can see where we all fit in.
Are you in freight sales with a book of business looking for a new home? Or perhaps you're a freight agent in need of a better partnership? These are the kinds of conversations we're exploring in our podcast interview series called The Freight Agent Trenches, sponsored by SPI Logistics. Now, I can tell you all day that SPI is one of the most successful logistics firms in North America who helps their agents with back office operations such as admin, finance, IT, and sales, but I would much rather you hear it directly from SPI's freight agents themselves. And what better way to do that than by listening to the experienced freight agents tell their stories behind the how and the why they joined SPI. Hit the freight agent link in our show notes to listen to these conversations, or if you're ready to make the jump, visit spi3pl.com.
Any questions so far?
Lots.
Yes, sir.
I was wondering, I don't know how extensive you guys have done the testing, but are there different plants that are more sensitive to space conditions than others? Do you guys have a sort of area of plant that is better for it that you guys are looking into? How does that work?
It's a really good question. So we have grown crops. Actually, the pictures that you can see on the wall above you, you can see Scott Kelly and Tel Linger eating lettuce, and then Peggy Woodson growing cabbage. So for instance, our cabbage crop didn't grow as well, and it could be a combination of the lack of gravity, but also like LED lighting or elevated CO2, like all of those things can cause issues for different crops. Some crops can do better, some crops not so much. And so this is where we can actually simulate those conditions here to figure out, well, what crops can we screen out, what crops can we plant, if that makes sense.
Yeah.
Yep.
How accurate was Matt Damon on Mars growing the potatoes?
Oh man, I love that movie. So, any scientist watching that movie, as a scientist, you're going to pick things out. I don't know how safe it would be to use species as fertilizer. That's, in my mind, I'm the point of contact for food safety here, and trying to figure out what are the hazards of E. coli to astronaut health. You don't want any opportunities for that. But also growing potatoes, that is something that is actually not new. So let me bring you over here. This model here that you see, this is called the biomass production chamber. It was active here at Kennedy Space Center at Hangar L from 1987 to the year 2000. And in this, it's basically a completely closed chamber, but it actually had different layers, like vertical farms. And NASA was actually vertical farming before vertical farming existed. And one of the crops that grew in there were hydroponic potatoes. So actually the movie kind of got some of its intel from research that we had already been doing here for 20 years.
Wow.
And so it's no longer existing now, but it's been, in terms of being a pioneer for what we call controlled environment agriculture, all of that actually started here in the efforts for space exploration.
Is that one of the GBE boxes?
Yes, it is. I was actually going to get to that. So Growing Beyond Earth definitely is an outreach tool that we've had in collaboration with middle schools and high schools in Florida. And so yeah, we have these in the classrooms where the students can actually grow plants and make recommendations for us here at NASA on what's the next crop for us to fly in space. And so far, we've actually gotten at least 2 crops as recommendations for us, and we've flown them as a result of the citizen science research that happens in the Growing Beyond Earth program.
That's cool.
I think one of them was dragoon lettuce and pop toy. Those were the 2 crops that they ended up recommending to us, and we flew them, and they grew great.
Huh.
And we actually have some dragoon going in one of the tanks now. I'll show you today.
Do you have any recommendations of, I'm an educator.
Okay.
I'm a director of STEM at a private school. I have a greenhouse that was just installed, and I'm using the agronomy aeroponic towers. So they're 8 feet tall, they dribble in 3 minutes, turns off 12 minutes. I can have between 54 and 144 crops depending on the density of the root ball.
Yep.
They go in the cocoa pod things. Is there anything that we can do, citizen scientist-wise, that you're aware of botanically, that we can provide data, do experimentations? I have a GBE box that we're also going to put in the classroom, but I have this big, huge greenhouse I can use. And it has a super, super duper, highly controlled system that's run by, not SunVision. Anyway, but all electronically controlled, humidity, everything is there. Is there any program that you can think of off the top of your head that might be possible for us to do?
You mean like something to test that would be beneficial for us, or?
Yes. Is there something, like, I use NASA's best curriculum for engineering. Is there something already out there that I might not be aware of? Because GBE was all I could find.
Yeah.
And you don't have to answer me now.
Yeah, no, because I've been working with some of the GBE educators as well, and I think we're in the process of coming up with a curriculum for something that may help us. Like, for instance, I mentioned menu fatigue and taste profile, and I know with the GBE boxes you can tune the color of the lights, and so I was actually kind of recommending that they see if they can modify the taste. Like, for instance, so in the microgravity environment, astronauts sometimes have reported losing or diminishing their sense of taste. And so a lot of them are asking for spicier foods. So I was wondering, well, can we modify the taste in space using the lighting that's already available?
Well, what about the intensity of the UV light that they get? I can vary that. Or is that less interesting than the color of the light?
Well, that is what I'm saying. You can change the color of the light itself. Light recipes, basically. And that will, in certain spicy crops, or like arugula, for instance, is one of the crops that I've been trying to push, because you can change the taste by changing, for instance, a ratio of certain colors. And so that's just one thing I was thinking of off the top of my head.
Thank you.
Yeah. So, but great question. Anybody else? Okay, I know we don't have much time. You got something?
If you want to keep going, you can. I was just going to ask what's going on in that room.
Yeah, so that's Greenworks. It's kind of like our miscellaneous area for like where we start experiments and we want to try something out quickly. If we have time, I will try to take you over there. But for now, I can mention you may see a lot of tall flowering plants in the corner there.
Yeah.
So we've got some projects where we're actually growing plants for teas. Like we've got chamomile growing, and so that we was trying to actually purposely grow it to flower to have potential plants that can be made into teas.
That's awesome.
Yeah. So, and I
Time on
think,
the ISS.
Okay, and since Matthew just mentioned growing teas and some of the other plants that they were experimenting on in the other room, I'm going to fast forward just a little bit to show you some of those plants and some of those teas that they are growing. So I'll hit play on that now.
Smells like tomatoes.
And if you couldn't hear in one of the other videos before it cut off, it's probably going to be a future story over on the NASA team, because they mentioned specifically that spill the tea is probably going to be a blog post or a social post in the future for the NASA social team. So I thought that was cool too. All right, and in these next couple of clips, we're actually going to be going to the different chambers and being able to take a peek inside of with some of these chambers and how they're simulating the different growing, I guess, experiences that these plants are going to be having, and also testing the actual plant health for when they face, some kind of adversity, in space and how they react to it in space. And it's really interesting that that just at the cellular level with a lot of plants and just even the human body in general, it reacts differently in space. And so they're on here on Earth and inside these chambers, they're trying to test those different environments. So here's what that process looks like.
But the idea of using these walk-in chambers is because, it gives us an opportunity to simulate the environmental conditions on space station. In particular, the CO2, but also temperature and humidity. Now, in this chamber, actually, this is a project that's headed by one of our postdoctoral scientists, Dr. Luke Fountain.
You get close.
The plants are growing on a hydroponic cell.
Okay, so I had to cut that video off just for a second there, but I'm going to bring up the next clip of him talking a little bit more in depth just about the different plant health monitoring and also the effects of light therapy on plants.
Reflective imaging, and even LiDAR. And this project, in collaboration with the USDA and the Army, is basically how do we use plant health monitoring to solve a problem. For instance, we're purposely droughting some of these plants. Starting tomorrow, we're going to stop watering the plants to see if we can actually image a stress response. If we can actually predict or see the plants getting stressed before they start wilting, it'll allow us to tell the crew, like, hey, it's time to make an adjustment or water the plants before they actually lose their food. And so plant health monitoring is an aspect that we're trying to push here for mission applications.
Bad days are coming.
No, they have no idea what's coming to them.
Let me get to them.
Excuse me?
Don't the astronauts request certain things?
Yes, they do request spicier food sometimes because they do have a diminished sense of taste because of the fluid shifts in microgravity. So yes, transit missions, we want to be able to, and actually I'm working on a project now where I'm trying to actually increase the intensity of a flavor of the crop by changing the light recipe. We have the capability, just haven't really tested it yet, so I want to try to test that to see if we can allow the crew that capability to do that. Oh yeah. Oh, a lot of the things, like, yes, like Thanksgiving, holidays, they request a lot of the things that, they would normally get from home, and we ship it up to them, for sure. Yep.
What kind of things are y'all 3D printing? I'm sorry.
Yeah, that's a good question. If I had more time, because I usually will show that stuff. So we do 3D print materials, like, for instance, trellises that we use to kind of train the plants. I think we might have some. We did have some.
Love that little clip at the end with one of the other creators that was on site, and we're all sort of kind of competing to get as much footage as we can, and so you can kind of see it not just in this video but some of our other space logistics videos. All right, and just to sort of round out this discussion and at the end of it, and apologies again if you were listening on audio, this is going to be much better for you if you actually watch the video, but I'm going to run through a few of the images that we were able to, that I was able to snap while on this particular part of the tour. So let's run through some of these images. Now, what you're looking at on the screen right now is basically one of the chambers. And so in front of each of the chambers, they have basically a lot of the different scientists sort of stats, the start date, the finish date, the duration, what they're actually testing for, environmental set points. So there was a bunch of these chambers just all over the room and all over the space that we were in. There were also different scientists that were basically walking around the tour and just getting their job done. So they paid us no mind. They were completely focused on exactly what they were supposed to be working on. So if you're looking at the screen, here are a few more images. Just, kind of, I thought that these were fun, just kind of showing off a little bit of the humor, very similar to the aliens farming the plants to enter into this part of the tour. But then also, some of the signage that they have all around, this one in particular saying gardeners know all the dirt, and that is some of the tea that they are growing back there that you can see pictured. Here are some other different, hydroponic systems that they were also testing as well. And so if you're looking at the little purple things, these are basically the water that they're trying to feed into the plants. Because if you think about it, you have to be very careful with how you water plants in space. There's no gravity, and so it's a little bit challenging to water plants in space. And so this was one of the ways and one of the methods that they were testing from a hydroponic perspective. Here were just some other just like random I think photos. What is this one? Yeah, these are different photos of different tours and things that that this particular division has participated in. Going through some of these other like sort of b-roll. If I scroll back one more really quick, you can see some of the different plants, the leafy greens that they were talking about. So that's going on in this particular clip of some of the astronauts that were able to, eat some of those leafy greens. And they mentioned that basically leafy greens, and the reason that they grow so many of them in space is because they reproduce and they grow really quickly. And they also survive a lot of different, environmental things here on planet Earth. And so it's thought that they would be able to survive better or be one of the more efficient plants to also grow in space, considering the protein count and the nutrition. Here's more of the tea that I thought was also really cool. Just, cool different video footage. You might have seen that earlier, but I'm going to play it again. Let's see what else we got. Oh, here's some of the chambers that I'm going through, and you can kind of see all of these different experiments that are going on. And in that particular clip, these are the poor plants that they were actually going to be drowning the next day, and just to stress test them in order to see if they'll be able to survive that stress test. And yeah, that kind of ends it for the B-roll. All right. Well, that about does it for this special episode of our space logistics series. I hope y'all enjoyed it, and hopefully you were able to watch it. And if you were listening, hopefully it was still enjoyable, even if you didn't watch it. But if you do want to watch it, I highly encourage you to check that link in the show notes, or head on over to our YouTube channel over at Everything is Logistics, and you'll be able to see the full version. But be on the lookout for other episodes from our space logistics series that are going to be coming out in the coming weeks. We're going to be talking about deep space logistics. We're going to be talking about what goes into a NASA launch. We're going to be talking about, the infrastructure that you have to set up in space itself. And then we're also going to be hearing from those scientists from NOAA. That is the National Oceanic Atmospheric Association. I think it's not association, it's something else. So I'm blanking on that. But we will get that. Hold on. I'm just going to look it up right now. So NOAA, yes, administration, not association. So administration, National Oceanic and Atmospheric Administration. So be on the lookout for that episode. I will have that acronym correct by then. So thank y'all for listening, and hope you enjoyed it. Welcome into another episode of Everything is Logistics, a podcast for the thinkers in freight. My name is Blythe Milligan, and we are proudly presented by SPI Logistics. And in this episode, I'm happy to welcome in Justin Fiaschetti. He is the CEO and co-founder of Inversion Space. And we're going to be talking about building the next shipping container and transporting it to and from space, which is super exciting. And then obviously, very, very relevant to this show, especially after doing our NASA series that debuted in August. And so as a little bit of a follow-up, we kind of talked about your company, Justin, on a recent episode, and was able to get connected with you and have you on. So I'm pumped to have this conversation. All that to say, welcome.
Yeah, thank you for having me on. Really excited to talk about this. Logistics is like what makes the world tick, and we want to bring a new modality to that. So excited to share more about inversion and what we're building.
And I have to ask, just like off the rip, like this feels like the most exciting, like just space in general feels like the most exciting industry to be a part of right now. Is that a similar feeling for you, I would imagine?
Yeah, there's a lot of really cool stuff happening, right? Over the last 10 years or so, getting to space has become very available, mainly thanks to SpaceX and them bringing the cost of launch down, but also the frequency of launch, right? They're flying, every other day, every 3 days, something like that. And so there's been this kind of explosion of entrepreneurship in the space industry. A lot of people coming from SpaceX, a lot of people based in Los Angeles. And it's a really cool domain to operate in, right? There's kind of a very high risk, high reward aspect where you can only test in space by going to space, right? You can't do stuff on the ground fully to see if it works, right? You can test a little bit, but at the end of the day, you put it in space, you see if your thing works, and then if it does, that's a really big reward for stuff.
And so how did you take me back to sort of that light bulb moment for you that you decided that, because I don't believe you have a history in or a career history in logistics. So how did you know that this was a problem to solve?
Yeah, so we founded the company or we came up with the idea for the company about 4 years ago at this point. And it was myself and my co-founder sitting around after dinner one night. We were doing the dishes, and honestly, we were just kind of talking about like what is coming next in the space industry. We were both working at rocket companies at the time, and what we realized was that space as like kind of like a platform offers the value of being able to cover the whole globe with very little infrastructure, right? Two use cases right now for space are communications from space. I think like satellite internet, Starlink is a kind of the prevalent example, or Earth observation, right? Taking pictures of the Earth. And so really what those are taking advantage of is very few things can cover the entire globe, including remote areas, at a cheaper and faster rate than you would be able to do terrestrially. And so what they're returning is data, right? They're returning bits, right? Information. And we asked ourselves, oh, well, what if you could return atoms back? And the kind of way we came up with the exact idea is a little funny. It was wildfire season in Los Angeles, right? The sky was like red from all the smoke. It was raining ash. And I asked my co-founder, I was like, hey, what if we could drop water on wildfires wherever they started, in a very short period of time, put them out before they got big. We've quickly realized that wouldn't totally work because you need a lot of water to do that. But then we started realizing, well, hey, like you can store cargo in space and have that piece of cargo have access to the entire globe, and land it very quickly. And you can, by doing so, create 1 hour delivery to the entire globe. So that's kind of where Inversion got started. Is we decided to go and build fully autonomous reentry vehicles that can store cargo in space, and then on demand deliver it to anywhere on Earth. And so the way it works is you take these reentry vehicles, you load them with the cargo on the ground, you launch a bunch of them into space, into low Earth orbit, and then and they kind of just sit there. They just hang out there until they're needed. And then once they're needed, you give them a GPS location to go and land at, and they'll fly fully autonomously and land within 50 feet of accuracy.
And so are the reentry vehicles are almost the warehouses that are in space. It's not necessarily like you have a warehouse that you're building in space and you're shipping goods to and from it. The entry vehicle acts as the warehouse, correct?
That's exactly right. Yeah, imagine that a shipping container is also the way you store your cargo around the globe, right? And that shipping container can get moved wherever it needs to get moved to. Yeah.
And so with I guess the cargo delivery, because at first I believe you're focusing on, sort of a Department of Defense or disaster logistics, healthcare related items in an emergency, remote areas, I believe as well. Is that an accurate statement?
Yep, that's where we're starting off because the main kind of thing we focus on at the company is providing enough value for the cost that this is. And in all of those settings, even today with current prices of getting to and from space, those close from a business model perspective. But as we bring that cost down through reusability, through just mass manufacturing, you start to open up many more markets as well that just want to have the ability to access the whole globe very quickly.
And so it's probably those high revenue items, like you said, stuff that you're probably going to make, money off of so that you can be profitable, so that you can continue to, run a business. And so I don't imagine, or do you imagine that, it's going to be like, I don't know, delivering sunglasses to, my backyard one day? Do you see that as like a future likelihood, or probably not because of the cost associated with it?
So when we think about the like terminal cost of this, right, where is this going to end up? We expect that it will actually be at roughly the same increment as going from shipping by boat to shipping by plane, as it will shipping by plane to shipping by space, right? It will be like roughly that amount of delta. And it will be actually even faster as a percentage basis in time between space delivery and aircraft delivery. So do we deliver sunglasses by planes today? Like, we don't, right? We deliver like big, high priority items, whether that be mail or overnight shipping, right? But we've gotten to the place as a society where the speed of shipping by plane, people are willing to pay for just because it's faster, right? Not because they necessarily need that item in a shorter period of time, but it makes more business sense. It makes more personal sense to have that cargo shipped by air freight rather than by ocean freight. And we expect that same thing to happen. So is it sunglasses? My bet would be like, and kind of like those kind of level of consumer goods. Sometimes, I would say, sometimes if it's really high priority, right? Sometimes I'll have, I guess no one would have thought 30-minute delivery of food would be something people would be willing to pay extra for when you could just go and drive to get the food. But turns out people love convenience. But I think that what we're building is a new platform, right? It's a new method of delivery. And there will be a lot of new business cases that we can't even conceptualize today that will come up because of this, right? If you go to a bunch of entrepreneurs and say, you can touch anywhere on the globe in an hour, what can you do with it? That's really exciting. Like, I'm pumped to hear about what comes from that.
So for a big moment, I guess, that happened in shipping is sort of the standardization of the container, and using the container, for cargo ships that can go onto trucks, that can go onto trains. I'm curious if some of the reentry vehicles, are they going to be sort of standardized, or what do those reentry vehicles look like? Because I believe you have Ray, and then you also have Arc.
That's right.
Can you kind of, I guess, break down what the standardization looks like, and maybe those different types of reentry vehicles that you're building?
Yeah, so Ray is our tech demonstrator. It's going to be launching in the next few months to space and landing off the coast of California. Really just meant for internal technology development, getting data on all of our systems that we can then go and apply to Arc. And Arc's kind of our main product, and we're really excited about that. It'll be launching for the first time in 2026. And that is what goes and does that precision landing and global delivery of cargo. As it currently stands, you can think about the reentry vehicles. I would call it like a Ford Transit van, right? Where you can store stuff in it and you can deliver it together. And that's like a good way to go right now, just because the economics of how expensive it is to put stuff in space at the moment favor that kind of like delivery and storage at the same time. And so like we're a little early to start standardizing the actual container inside of the reentry vehicle, right? A reentry vehicle you can generally think about as it's like the equivalent of like a train or a truck or a boat, right? It is the method of movement, right? Rather than the method of storage at a high level. We are combining those two to start, right? We are saying we're going to have a payload bay inside of the reentry vehicle that is standard, but it is intrinsic to the reentry vehicle. It is removable, to some extent, right, to access the cargo. But the cargo is not meant to be necessarily stored inside of the payload bay, independent of the reentry vehicle, right? There's power constraints that, or there's power hookups, there's software hookups, there's mechanical hookups that require the reentry vehicle to start. But that will probably change. It will probably change over time to where there are various different sizes of reentry vehicles. There are various different types that you want a standardized set of cargo so that the high value expensive thing, which is the reentry vehicle compared to the payload container, can be separate and they can be interchangeable. So you can have 5 reentry vehicles and 50 payload bays with different types of payload. But to start, the overhead and the like total like capex to build out that method would be too high. And so you start with that kind of Ford Transit van where it can do both.
That that's I guess it's really reassuring to me because I was thinking before this interview that there was going to just be a bunch of just giant warehouses up in space. And as someone who I think a lot of us all love gazing up at the stars, and there's kind of a little bit of controversy around a lot of the satellites that are going into space, and they're messing up the stargazing. And I just thought to myself, well, what if we have all these big ass warehouses in space, and then they're just blocking it even more? So it makes me feel better about the whole just I guess stargazing ability, is that you won't have well, maybe you will have giant warehouses in space. I imagine that's kind of what the ISS technically is, even though the humans can live on it as well.
Yep. And I mean, I'll give an example here, right? So the International Space Station is, could be that giant warehouse, right? And then you might have like smaller reentry vehicles that pop off of it. The International Space Station was $100 billion to build, right? And so that's going to be a longer term thing, right? We'll get to that eventually. To start, right, we'll have the capsules have the cargo itself. But the International Space Station is about the size of a football field or so, which is roughly the size of like a Airbus A380, right? The largest airplane that you have flying. But the International Space Station is really far away from you, right? It's about 375 to 400 kilometers away. So it's tiny. It looks tiny compared to an airplane flying over top of you. And there are, at any given time, 5,000, 10,000 airplane in the sky. And that's not a huge deal for stargazing, right? And for kind of astronomy. It has some impact, but not a huge impact. So we actually think that from that perspective, it will end up being even more favorable because it's just so far away, and they're relatively small compared to the moon or something.
Right. So I'm curious as to, because especially for logistics, I've been working in logistics for a little over a decade now, and it's seen sort of this tech evolution, especially since COVID. When the world shut down and everybody kind of found out how important supply chains were or are. And I think for a lot of folks within the industry, especially a lot of the veterans, they are apprehensive to new technology to change. I'm curious I'm wondering if maybe your advantage of not working in logistics has helped you create a new logistics company because you were almost on the outside looking in. Were any like logistics professionals or veterans, consultants kind of helping along the way with, sort of the early days of Inversion, or even now, or has it really just been like, what can we think of that's new, and let's carve this new path?
Yeah. So, we have a lot of folks we talk to, and I try to learn from like literally every place I possibly can. We try to take lessons from existing logistics systems and things like that. But especially on the military side, we have like a lot of folks we talk to on how they do logistics and how they do global force projection and that kind of stuff. At a fundamental level, like logistics today are almost entirely about cost reduction and timeliness, right? Like the way that you win as a business in logistics is you are like 2 or 3% cheaper than the next person, and then and maybe you run like a little bit better at being on time, which is like fine because like airplanes are commoditized, boats are commoditized, like that is like we are at a technological limit effectively on all of those systems, right? Yes, there are some things you can do to optimize, but like the built world is really great at moving cargo right now in large masses. Our perspective is generally that like if you can do something with the old paradigm, you should do it with the old paradigm. Like if you could do global delivery of cargo in under an hour, like with an aircraft, like you should probably go do that because it's gonna be like easier and like they already exist and you don't have to like reinvent the wheel. But like fundamentally, it is not possible from a cost or a time perspective to have that fast of access to, middle of the ocean, remote areas, and broadly just you would otherwise have to have an entire global supply chain as an individual user, right? Whether that be the military, Red Cross, whomever. And so what we are offering is like at fundamentally a different optimization than what current logistics optimize around. Yes, we need to reduce costs as much as possible. But we're not fighting for percentage points, right? We're fighting for like 10x speed reduction or increase in speed. We're fighting for like, can we cut the costs in half in the next 2 years? Can we cut it by 10x in the next 10 years? And as such, like our volumes also aren't high enough right now that like traditional logistics planning methodologies work super well. Like how do you distribute like 15 things around the globe, right? Like that's a lot simpler of a problem than how do you distribute like 50,000 shipping containers around the globe, or however many there are. It's probably more than that, it's my guess. So we think about it a lot that way, but fundamentally, we're not trying to build technology to solve or to be better at an existing thing. We're trying to build a new capability for humanity, and that does require some technology, innovations to go and do.
Yeah, I mean, as you were talking, I was just thinking of, obviously the disaster that just happened after Hurricane Helene, and there's so many people that are stranded on tops of mountains and roads. You can't get to these people, and sometimes they're trying to do helicopter flybys and things like that. And so, is that a situation where a company like Inversion could come in and drop some much needed supplies in areas that are greatly impacted where traditional transportation methods just don't work?
Yeah, absolutely. The nice thing about what we're doing is the cargo is location agnostic. So if it's a hurricane in in North Carolina, if it's an earthquake in Japan, if it's a tsunami somewhere, generally you need food, you need water, you need medical supplies, right? And you need like some sort of shelter or power or for heat. And so we don't need to pre-plan where that cargo is going to get delivered because we won't know, right? And so we can be very responsive in those settings where, hey, there is a lost hiker, right, in the middle of Alaska or something like that. And they probably need roughly the same cargo as, the stranded family from a hurricane. And our goal is to make it so that whenever that happens, right, we can bring that cargo down and support them. Now, right now, it's too expensive to do that for an individual to pay for that, right? We wouldn't expect that to be a great business model for you or me to, constantly have access to that cargo. But what we can do is basically distribute the costs, right? So, just like AAA is a distributed cost, where if you need roadside assistance, great, you can get it, but you don't have to pay for the tow truck always, right? You can share that cost with a bunch of people. And that's also kind of how Red Cross operates a little bit, right? Where you and I could benefit from Red Cross, but we don't have to necessarily fund the whole organization ourselves. And we see that as being, especially on the kind of disaster relief, humanitarian relief side of things, how that will generally work, where there's a collective payment in order to deliver supplies to individuals.
And so walk me through the process of, say I'm a Department of Defense, worker, or maybe, disaster logistics worker. Am I booking a load? Am I tracking the load? Like, what does the whole, like, I guess, start to finish process look like?
Yeah. So from our perspective, or from the customer's perspective, the Department of Defense or the Red Cross worker, all they do is they say, Inversion, we would love to have this type of cargo be able to access in these areas at any given time, right? They hand us the cargo, and then we say, great, let us know when you want it, right? And then they tell us when and where they want it, and they will get it. Right, we take care of all of the logistics of mounting the hardware in the vehicle, or sorry, the kind of cargo in the vehicle, launching it, monitoring it while it's in space, doing any sort of debris avoidance that we have to do. And then once they need it, we tell that piece of cargo, that reentry vehicle, to come down and land where they asked it for. So we want to abstract away all the complexities of operating in space for our customers, right? A good analogy here is the internet, right? It used to be that you had to be an internet company to use the internet, right? You had to have like an IT staff and like software or like developers and like to have an internet presence, anything like that. But now every single company is an internet company, right? Nike sells tons of shoes online, but they're not, you wouldn't consider them a tech company or an internet company necessarily. And so that's kind of our goal, is that everyone is using space as a cargo delivery method. Doesn't mean they have to be a space company, just like they don't need to be an an airline company today to ship cargo, via DHL or FedEx or whatever.
And is it the same kind of cargo in each reentry vehicle, or is it a different cargo for different purposes? Like, Department of Defense probably has, maybe theoretically 15 of their own that they can put whatever they want in. American Red Cross has, their own that they can put their own supply in, or is it just, IV bags all in one or something like that?
Yeah, so each type of cargo would have multiple reentry vehicles that it's in, so that you have that kind of coverage, right? It's like a network of those capsules to make sure there's one over top of everywhere at any given time. So let's say I would have, a set of capsules, a set of reentry vehicles with, IV bags. I have another set with, radios, and another set with communications equipment. And they would all be in space, and they would kind of be their own network, basically.
What about the cargo on reentry? How do you know if it gets damaged, or if, I don't know, like radiation affects it? Or that question actually came from a friend of the show, Thomas Watson, who's also a logistics professional and content creator. So he was really excited about this interview as well. And that was his question: is what happens to the cargo on reentry? If is it insurance involved in this process at all?
Yeah, so there are kind of three phases of flight for the cargo. There's the launch while it's on the rocket, there's the staying in space until it's needed, and then there's the reentry. Each phase has slightly different challenges that we try to take on as inversion, so that the cargo doesn't have to worry about it. So for launch, for example, it's a very high vibrational environment, right? It gets shaken around quite a bit. And so we dampen the payload as much as we can to make sure that the cargo doesn't see any more vibration than it would on like a truck getting shipped across the country, which actually has surprisingly high vibrational and shock loads. I was surprised at that. Once you're in space, now you're looking at, okay, radiation, temperature, pressure, that kind of stuff. And our payload bay is pressurized. It has temperature control. It has humidity control. We use like a dry nitrogen so that you don't have any oxidation. And it has radiation shielding to the extent that's needed. So our goal is like, it's literally just a warehouse on the Earth, except it happens to be in space, right? On the radiation point, a good example is, we have people and cargo up in space currently for, extended durations on the International Space Station. There's a very thin shell of aluminum that is what protects it from any sort of damaging radiation. And so we have blood in space, we have medical supplies in space, and NASA signed off that all of that is totally good for all of their astronauts, and that will be the same for this cargo. Once you then re-enter, once you kind of enter the atmosphere, now you have to deal with the heat of re-entry, right? It gets very hot, the temperature of the surface of the sun on the outside of our vehicle. And so we have special thermal protection materials that surround the re-entry vehicle to make sure that that temperature doesn't get into the cargo. And we also can do an actively chilled system for the cargo. Once you land, you just grab it as if it was dropped from a drone.
And it's dropped via a parachute, right?
That's right. Yeah. So once we've once the reentry vehicle has entered the atmosphere and we start to get close to the ground, call it like 10 to 15,000 feet, we deploy our parachute. And the parachute is steerable, just like a skydiver's parachute might be. And so that lets us do that kind of very accurate targeted landing. Rather than like if you just had like a big round parachute, it could drift if there's winds or what have you. And because we land under parachute, rather than like using like wings and a runway, like a space plane might, or having a rocket engine that fires to slow us down, because we're under parachute, we can land near people. We can land in austere environments, so we don't have to have a landing site necessarily perfectly clear. And because it's steerable, we can avoid obstacles like trees and that kind of thing.
So is it just kind of someone sitting in an office, maybe with like a VR headset on, that's steering the parachute, or how does that work? How does the steering work?
So it's actually fully autonomous.
Oh, wow.
The ARC does it all on its own. So ARC has a bunch of sensors on board to know where it is in the world, to know how far it is off the ground, to know where things are on the ground. We use a combination of computer vision and classic like guidance, navigation, and control systems in order to like land super accurately. And you can adjust the landing site if you have to. And so it can like divert to a different spot if you happen to move, or if the landing site is no longer viable. And then flies. And we do this cool maneuver at the end where we like flare the parachute so that we softly touch down, just like a skydiver kind of runs out their landing. And that means that the cargo doesn't have like a big load when it hits the ground.
Oh, that's super interesting. And I'm curious for for a lot of, I would imagine, Department of Defense items, I'm sure you get asked the, security question of how do you
Yeah.
protect this kind of cargo in space? And so what I mean, I'm sure you can't reveal everything, but what is sort of the general overview that you can tell us?
Yeah, so in space right now, there's kind of a big kind of realignment where space is no longer a peaceful, like there's no one else that can touch our satellites. It's what's considered a contested environment now. Countries like China and Russia have the capability to shoot down satellites. China has the capability to move satellites, and so that is a problem that every space company is wondering about and looking at. At a fundamental level, though, it's really no different than if you have like cargo on an island somewhere or at a base somewhere, right? You have people know where it is, and you need to make sure that you can either move it quickly if they're coming to grab it, or make sure that they don't know where it is as easily as other cargo might be. So there's not like I think it's less of a risk than what most people would expect. The other thing is because we have like a network of capsules. Sorry, I use capsules and reentry vehicles interchangeably. So sorry if that's been confusing to the listener. Because there's a network of them, like if one gets captured, like there's another one that's coming like 20 minutes later. And so it's very difficult to capture all of them.
Yeah, because I was watching this document, and I'm not sure if maybe you've seen it, the Wild Space, or I think it's Wild Space, that's on HBO, and it's a really interesting look into what's kind of the unregulated environment of space and how it really is like the Wild West. Have you seen that documentary yet?
I haven't seen that. Is that the one with like Rocket Lab and Astra? Am I thinking of the right one? Okay, cool.
Yes.
I saw a bunch of stuff on Twitter about it, but I haven't seen it personally. But I'm quite familiar with those companies. So
Yes, it's very fascinating look into just sort of the business of space and how it's evolving so quickly. And one of the crazier stats is that we have about 8,000, I think, satellites in orbit, lower Earth orbit right now. But in the next 10 years, they estimate it to be over 100,000. And so it's just this I guess area, it's almost like Antarctica, where the whole bunch of, sort of the global nations are going to have to come together and make some kind of a loose agreement. And so it's a little surprising that they don't have that yet, but I imagine it's probably going to take something happening in space, I think, for all of these countries to kind of wake up and maybe come up with that.
Yeah.
It's one of those things where I think I don't know if I want regulation, and then I don't know if I do want regulation. It's kind of like that middle ground of where policy sort of stands. And I imagine that, sort of working with the government on these things, are they excited about going into space and like space logistics and things like that? Or is it just become like another part of like a necessary part of the program for them?
Yeah, so space has become kind of like this really exciting thing within the Department of Defense. Obviously, the Space Force was stood up maybe 3 or 4 years ago at this point, and so people are really starting to understand that space influences all aspects of the Department of Defense, whether it's GPS or communications or imaging for understanding troop movements and things like that. And cargo delivery, like I was kind of explaining at the beginning, is really just another evolution of what's already being done. Right now, we're taking pictures and transmitting that back to the ground. Now we're just going to store cargo and transmit that back to the ground. like I mentioned earlier, also, like fundamentally, there's no other way to move as fast as you can and access as many parts of the globe as quickly as delivery from space can. And so the Department of Defense has like a number of programs that are that they're talking about and have made announcements about around like rocket cargo and space delivery and that kind of stuff. And so I think people are really starting to understand like, oh, this is like a very valuable capability. And it's the kind of capability that once you have, it's kind of hard to go back from, right? Like as in like, uh, once you are able to access the whole globe in under an hour, you never want to give up that capability. And in fact, everybody else now needs that capability too, because you know, if the U.S. can access, or maybe just one part, like let's say the Air Force can access every part of the globe in under an hour. Well, the Navy is going to want to be able to do that too, and so is the Army. And then our allied nations are going to want to do that as well, right? The U.S. or sorry, the U.K., Australia, Japan, those types of countries are going to want to be able to maintain kind of parity of capability. And so just like once the aircraft was invented and introduced, it was kind of like a, yep, we need this and we're always going to have it because it's so valuable. That's happening right now with delivery from space.
One of the things you mentioned earlier, and from what I understand, there are companies now that do this, that track debris
Mhm.
that are in space, and I just think that's it's so crazy how the parallels of logistics and tracking that are right here on Earth are following us up into space as well. And
Mhm.
so I'm curious, how do you account for space debris and something as small as a screw that could damage one of your vehicles, or is that
Mhm.
even a worry?
Yeah, so it's less of a worry than you would think.
Hmm.
The debris is roughly pretty well tracked, and it's very predictable. Like orbits are very predictable for the most part. You can project months in advance if you're going to have a conjunction event. Uh, we have our arc vehicle has propulsion on it, so it's able to move within its orbit. And so it can like raise its orbit, can lower its orbit to avoid any debris that it might be coming up against. And so like space debris is this kind of like it could be very scary, but it is manageable. Just like having thousands of airplanes flying around would have been very scary if there wasn't like flight corridors and altitude requirements and stuff like that. And all of that is kind of starting to get put in place, just kind of by like de facto. Like it's not necessarily like being mandated, but people are being very careful about where they're putting stuff for the most part. So unless there is like a major event, and even if there is a major event, it only causes issues in like a single orbital plane, and at like specific altitudes. So it's not like all of space is then just like completely destroyed. It's more like this one area has like this one area within an orbit has a bunch of debris or contamination, and so you just don't put stuff there until it degrades. But the other final point on debris is like, well, yes, it takes a while. Debris orbits, they degrade, so it will eventually enter the atmosphere. And so as long as you stay low enough, that happens in like a relatively reasonable time, like 5 to 10 years. So it's kind of like self-cleaning. When you get higher altitudes, it like never comes down, and that's kind of a problem. But yeah, we think about debris not a ton, and it's also nice because we bring everything back with us, so we're never like leaving stuff up in space. So we think that that's going to probably become some of the norm in the future.
It is kind of crazy how shipping lanes are evolving up into space. And I didn't even think about the different sort of orbital paths. I just thought, once you're in the lower Earth orbit, like everybody's kind of in the lower Earth orbit. But that would make sense that if it's going to burn up eventually for a lot of that debris.
Yeah, like you can think of low Earth orbit as like the Pacific Ocean, right? And like within the Pacific Ocean, there's a bunch of different shipping lanes. There's like generally understood of like where you go, where you don't go. If you're about to have a collision, who is responsible for correcting. Same stuff in space.
What about on the maintenance side of things? watching, sort of the infrastructure being built in space, one of the bigger sort of light bulb moments for me was learning about, different companies that are actually repairing satellites in space.
Mhm.
What happens if one of, an arc goes down? Can you perform that kind of maintenance on it in space, or is that something where you would have to almost maybe transport it back or just burn it up in orbit, or what happens there?
Yeah, so for ARC, if something goes wrong, depending on how critical, we'll generally just bring it back to land it in the US, and recover it, refurbish it, and refly it, right? Let's say like, one of the sensors goes bad or something like that. That's pretty easy and straightforward to do. Um, like maintenance on satellites is an interesting topic, and we could go down a huge rabbit hole here. But you have this problem where the cost of the because you need another satellite to go maintain the original satellite, right? And you need to launch that other satellite. And so then you start asking the question, well, why don't I just launch a new one of the satellite that I have to go and fix, right? And so like an analogy would be like, imagine if you needed an ocean liner to go and fix an ocean liner in the middle of the ocean. But once you've fixed that first ocean liner, that maintenance ocean liner is no longer useful. It's like, well, why wasn't that ocean liner just itself the thing that, why wasn't the maintenance one itself the valuable and usable system? So I actually, maybe slightly different than the industry, like don't believe in like satellite maintenance in low Earth orbit. For like further orbits, it might make sense. But there's this weird economics thing, which is like, it's easier just to like fly a new one, right? And it's like cheaper to go and fly a new one. And usually the sensors will have been like upgraded enough that you want to put a new one up anyway.
Oh, true. Very true.
So, but for ARC, because ARC's able to come back, we can reuse it, right? And so now you start to look at, well, now for context, satellites are all single use today, right? You put them up, they last for a few years, 5 years, something like that, and then you have to put a new one up. And like that's like continuously happens. For ARC though, we can put it up. After 5 years, we bring it back, we refurbish it, and we can fly it again. So now you have that same piece of hardware being used, 4 or 5 times. It actually brings the cost per mission down substantially, compared to just a single-use satellite.
Yeah, I think it's the reusability of items going to and from space and in space,
Mhm.
I think has been the biggest game changer, especially with SpaceX and Rocket Lab. How
Mhm.
do you are those I believe those are the two companies that you use that Inversion uses to launch into space, correct?
Yeah, so we're flying on SpaceX for our first mission, for Ray's mission that's coming up soon. We've yet to announce who we're flying with ARC, in 26. So that should be coming soon, though.
How does that for folks who may not know, and I'm wondering if this may be true for your future, instance, is that from what I understand, you can just talk to SpaceX and then they send you a link to book a flight to go into
Mhm.
space, and then you book it, you pay for it all online, and it takes about 15 minutes.
Yep, no, exactly. I forget the URL, otherwise I would give it right now. It's like SpaceX slash like launch or SpaceX slash like rideshare, I think like that. And you can literally go in and put your credit card info. I think you put your credit card info in. It's literally that simple. There's some like back end paperwork that happens afterward. But they've streamlined it a ton. It used to be that like you had to know someone at NASA, and NASA had to like do this whole prioritization and stuff. But with SpaceX, it's pretty great. You like go and you book your satellite. And once you book it, there's like testing and stuff, and like making sure that your satellite won't break apart on launch and hurt other satellites in the rocket itself. But they've made it like super streamlined and super straightforward. I think there's still like a lot of improvement that could happen generally. This is kind of like V1 of that. Um, our goal is a similar thing, which is like you go online, you book it, and you literally just hand us the cargo, and we take care of everything else. Um, SpaceX isn't quite like that because they serve other space companies, so there's not a need for them to do that. But we want to make it so anyone can put cargo in space, and have it delivered when they need it, without consideration for any of the space aspects of it.
Oh, that's super interesting. So I would imagine you would have a facility here in the United States where you're
Mhm.
storing some of these goods before they're added to one of the vehicles before it's launched.
That's right. Yep, exactly, exactly. So we would have it where Red Cross, let's just use them as an example, would give us a bunch of cargo, give us a bunch of pallets, and we'd have an integration facility, probably on the West Coast, maybe on the East Coast. We would integrate their cargo into our ARC vehicle. We would then put ARC onto like a SpaceX rocket and then launch to space.
What's been the most challenging part of this whole journey for you that was maybe also surprising that you didn't think was going to be that challenging?
Yeah, I think that like uh, just generally, space is a hard place to build a company. Like if you're building a software company, you can like write the software, make it kind of work, launch like deploy it, and have customers start to use it and test it and upgrade it over time. Space, you don't really get that opportunity. You kind of get that one shot, right? You get one launch, and everything has to work. And so there's a lot of stuff that has to come together, right? There's thousands of parts of the vehicle that all have to come together at the same time. So supply chain is a big problem on that, making sure that you're getting parts at the quantities you need when you need them. Right? If we have a 3-month delay, a month delay on a single part, we're not flying, right? And so I think that the biggest surprise was how different building a hardware company and a space company is than building like some AI company or software company, right? I envy them because they can go on and online and just like buy more servers with AWS, and now their main asset is scaled. Like you can't just do that in a hardware business, right? It takes time to build stuff, and so that is always an interesting thing compared to some of the other startups that we spend time around.
Yeah, I just did an episode on the company Hadrian, who is
Mm-hmm.
trying to, reinvent American manufacturing using a combination of legacy knowledge from those older workers that are going to be retiring soon, with automation and robotics. And they're focusing on the same industry. So aerospace, Department of Defense, these, the source of the
Mm-hmm.
product, and these lead times is just something that, is a complaint that I've heard in that store, or doing research for that story, is that it's a problem just across all industries, but it appears to affect the aerospace the most. Is that just an outside perception?
No, I think that's like roughly correct. And the reason is that there's very few suppliers for space-rated hardware. Like most space electronics, as an example, have to be they're different than what you would use in like a phone or like a car or something like that. You can sometimes get away with automotive grade components, but you generally don't. The other thing is because the environments are so intense, all of your materials have to have like material certifications all the way back to the mine they were mined at, right?
Oh,
So
wow.
you need to be able to track everything that whole way. So you can't just go buy some like random aluminum from Home Depot. And so Hadrian is a good example. They're a great company where they deal with a lot of that, getting that metal and then machining it in a very precise way, such that it can be reliably work how you intend it to work as the designer of it. So part of the reason that is that the space industry, while each unit is generally very expensive, right? Each satellite could be up to $1 billion, usually nowadays around $15 to $20 million each. There's not many. Like 8,000 is a lot of satellites, but like 8,000 cars is nothing, right? 8,000 phones is nothing. 8,000 aircraft even is basically nothing. And so your just volumes are so low that like a supplier might produce like 100 valves a year, right, for a satellite, or for various different satellites. And if they've sold all 100 of them, it's going to be another year until you have another 100 or so. So you're kind of just dealing with this like low volume, high value aspect where every single component is like that, rather than like consumer electronics where like a touchscreen is made in the millions. There's really not many things in the aerospace industry made in the millions quite yet.
Are there any other, sort of cool startups outside of your vertical that are doing cool things in space, or really interesting things in space?
Yeah, I mean, there's a lot of folks doing a lot of cool stuff. everything from like asteroid mining, which is like, is like a crazy endeavor, which could turn out to be very cool, to more satellite communications. Like at a fundamental level, you have to ask the question of like, what is the end customer for something you're building in space? Because there's a lot of people that want to build cool technology, which is great, but who's actually buying it? Right now, there's only two demonstrated business models that don't rely on the government, and that's internet and Earth observation. Everything else is like a one-off NASA mission or something like that. Like even the International Space Station is like just funded by NASA. So there are companies that are starting to build like commercial space stations for space tourism, and like that might become a big thing. But a lot of the companies right now are just trying to innovate on the two existing verticals of internet and Earth observation or pictures. And so there's this kind of new crop of satellite imaging companies that use synthetic aperture radar. Basically, it allows you to have like it's a different way to take pictures. It allows you to have like way more fidelity in the image, as well as see through clouds and a bunch of cool stuff. And so that's starting to get, remember, we were talking about that kind of like getting 5% better or 10% better, and that wins you the market. Those are starting to get to that place where if you're 5%, more resolution on your pictures, or if you can see through 10% more clouds, like you start to win that market. And so it's kind of interesting seeing that different stages of the space industry are at different maturity levels, where imaging is probably the most mature, then internet is probably the second most mature. So and then where we're going, which is delivery, is kind of at this nascent stage that has a lot of potential, and it's kind of like ripe for the taking.
Give us a sense of what the company Inversion looks like. I know you're based on the West Coast. Are you doing West Coast launches? I think you said maybe Florida. What does the team size look like? Can you kind of give us that eagle eye view?
Yeah, absolutely. So we've been around for about 4 years now. We are about 35 people today. We're scaling up to about 100 or so in the next 12 months.
Wow.
We're based in Los Angeles. I'm actually in our new facility, which we're really excited about. So we have one facility in Los Angeles, and we have one out in the Mojave Desert, where we own 5 acres of land, where we do all of our testing. So we do like rocket engine testing, explosives testing, that kind of stuff out there. We launch and land right now out of the West Coast, but eventually we'll be launching out of basically every launch site that people operate out of, whether that be in the US or overseas. Landing right now, we'll have our first vehicle, Ray, coming back from space in like end of January or so, with the launch coming up in the next few months. And that will be that kind of first proof point, the first time we've gone to space as a company and come back. We recently got our regulatory approval to do so. So within the kind of like reentry world or launch world in space, getting FAA approval to do that is like a huge deal. Like you might have seen that SpaceX was blocked from launching their Starship rocket for like many weeks because the FAA was not approving them. And we were lucky enough to get that all finished up well before our launch slot. So yeah, we're scaling, we're building, and we're only flying one Ray vehicle. That is again just very much a tech demo, just for us internally to get as much knowledge as possible and as much data as possible. And we're already kind of midway through the work on ARC, which will launch for the first time in 2026.
That's awesome. Is there anything else that you think is important to mention that we haven't already talked about?
I don't think so. I think that like the high level of inversion is eventually you will see reentry vehicles coming down to Earth, streaking across the sky as much as you see airplanes right now, and we will think nothing of it, right? It will just be a normal occurrence. And if you look across like the millennia, transportation modes have very much defined eras of humanity. Whether it was when the first ocean-going ship was built, or transcontinental railroad, or when aircraft that could fly across oceans were finally popularized. Each time what happens is that society gets closer together, right? The world shrinks in some ways where in 24 hours, I could be anywhere on Earth right now. But like, what about in 1 hour? How does that change the world? That's what I'm most excited about and what kind of gets us out of bed in the morning to go and build Inversion.
Yeah, it's definitely something that is super exciting. I mean, I know there's, a lot of doomers who look at stuff like this and they are almost a little scared of it, but it's one of those things where it's the age of, I think, new exploration, and for our species to be able to continue to push the boundaries. I mean, there's no other places to discover on Earth except for like the bottoms of the ocean, and who
Yep.
knows if we're going to do that. But out into space is sort of that next frontier, and I find it incredibly exciting and fascinating, and I really appreciate your time today and sharing your expertise and insight on building out this new shipping container in space. And so, Justin, for the audience, where can they learn more about Inversion? Where can they connect with you? All that good stuff.
Yeah. Inversionspace.com. That is kind of like where we have everything. And then on Twitter, I think we're at Inversion Space, and I'm at JC Fischetti. Yeah.
Well, that's awesome. This was a great conversation. So thank you so much again, and hope to continue to watch Inversion grow in the future.
Yeah. Thank you so much. It's been fantastic.
Absolutely.